let's do this. Mark, let me go to Mark here.
Okay, we'll try this out. Hopefully the air compressor won't turn on.
Yeah, so, and again, thanks to Mike. Sorry for the
Mike Gamble's.
Thanks to Mike. Sorry for the.
Yeah, thank you very much, Mike, for that presentation. I'm actually working on one of the devices that he talked about. Right now, we were breaking a whole bunch of drill bits because I didn't get the feeds and speeds fit in right. But right now, it seems to be going just about right. If you've been here on APEC before, you might have seen this. This is the 3-inch diameter brass gyros with the motors like inside of it. And Mike pointed out that I have the axis of rotation or axis of torque right on the center, and that needs to be adjusted. And so we're making an adjustable arm that will stick out from the base over here and allow us to put the gyros in different positions. And as I'm chopping them out, the drill bits started breaking. Apparently I was going for trying to bite off more than the bit can chew, literally. Anyways, moving on, other projects. Sorry, during the anniversary, we couldn't really get any live experiments going. There was just too much stuff going on. But we have made progress with a couple other experiments. This is the, oh, there goes the compressor. So this is the, let me try shutting it off. Hold on one second. I can reach it from here. Okay, so this is the amplifier for the warp drive experiment that we're working on, which basically has two standing waves interacting with each other, and they're supposed to create a change of density of space-time, or the space-time metric, by forcing two standing waves into each other. That's what that round antenna back there is for. We opened it up because it wasn't turning on, and also this gauge was broken, and luckily the supplier that sold it to us, who got it from Sandia, was also given an extra one of these little gauges. So I just need to plug that in there, and we'll get this amplifier running. This goes from 1.95 to 3.8 gigahertz at 200 watts. That's a pretty hefty amplifier. Oh, another thing we got going is our massive power supply. This is going to run all the klystrons in the lab. It's capable of 12,000 volts, 15,000 watts. It's sort of a home build over here. There was no power supply on the market that I could find that can, output this kind of power. So we had to build it ourselves. And there's a nice auto transformer over here to control it. It's running pretty well, but the newer klystron that I got for the Alzaphon experiment, which Bob, you probably like this. This involves dynamic nuclear orientation, and I call it coherent matter as well. You're the first person I've heard who used that term as well. But what I mean by that is all the subatomic spins are all oriented together. They're all coherent. And that's what we're trying to do here with this experiment, which involves a klystron that goes through a whole bunch of waveguides into a tuned cavity at the end. And that sits inside of a large electromagnet. It's like a 1-ton electromagnet that I have over there next to the Faraday cage. And using dynamic nuclear polarization, we're trying to, or pulsed dynamic nuclear polarization, we're trying to orient the subatomic particles' spins and make them shielded from gravity or the effects of inertial mass. So that's where that experiment's holding. There's one of the klystrons that we got were broken. We took it apart for parts. This one is outgassed. So hopefully sometime this week, we're going to get the vacuum pump up and running and pull a better vacuum on it. We have to connect the new tube and everything. So that's another project we have going on over here. And here is here's the electromagnet that I was talking about earlier. We also have the Grebennikov beetle wing experiment, which I'm not really sure how to set that up. And from what I heard today, it might not even work, but we have the parts, so we can try that out. If anyone has any recommendations on how to set that up, let me know and come down to the lab. We could try it out. Also for and this is the final thing, I believe. We're building a laser interferometer table made out of the special G10 plastic. It's some sort of composite material. It's extremely stiff. It's stiffer than aluminum. And the reason why we're using this base is because we want to be able to test certain experiments that involve high voltage, high frequencies. And if you had aluminum in the experiment, that would disrupt the experiment and ruin the results. This is the warp drive experiment that I told you about earlier. It's tuned to about 2.1 gigahertz. That's the wavelength of the radius. And you're supposed to have a standing wave on top, standing wave on bottom, interfere with each other in the center. And we could also throw in high voltage because I threw in a capacitor as well, which would be basically a short to the high frequency, but that would allow us to put up both a high voltage standing wave interference and a high voltage field together, and we can check them for different types of forces. So that's pretty much what we have going on at the lab today. And oh, the bit has not broken yet, so we might just get there today with this experiment. This is probably 2 hours out. So I'm gonna stay here tonight until that's completed. Bob, I want to ask you, what did you mean by coherent matter?
I mean, it was proposed a very long time ago by Bose-Einstein, Bose, the Indian chap, and Einstein, that matter could cohere. And it was first done in 1996 with a series of alkali metal atoms by lowering their temperature to around absolute zero. And what you need is the same isotope. So for instance, cesium-133 would be a good choice, or sodium-23 would be the same choice.
What do you mean by cohere though?
I'm getting there. So an atom isotope has can be described as a de Broglie wavelength. Ordinarily, because each atom has a different temperature, the wave function description of it is different for each one. They have a different wavelength, so they can't cohere, even though they're the same thing. And so what you do is you create a Bose-Einstein condensate by cooling it down to absolute zero. And in absolute zero, or very close, the wave function of the same atom isotope ends up being the same de Broglie wavelength. And so they can then become one macro quantum object, and they effectively become in sync. So coherent matter is something with the same wavelength and the same phase. So you can think of coherent light as the same frequency of light and in the same phase, and that is what's called a laser. You can have a Zaser, which is sound. Like, so for instance, if you go into a church and everyone's singing a different note, well, they're different frequencies of sound. So it's just nonsense, isn't it? But if you, for instance, all start exactly the same time with exactly the same sound, and it's all purely in phase, you have a coherent sound. What you think about that is having the same with coherent matter. Now, if you go and look at the Lockheed Martin patent that's awarded in 2013, they've built off a lot of work, and I've discussed that in several of my presentations. But essentially what they found is that using a process that was developed by Aharonov Bohm in the 1950s, you can get matter into phase and into sync. And that you can actually do this.
What component of the matter is getting in sync?
Sorry?
What component of the matter is getting in sync?
The wave description of it rather than the particle description of it. It basically, it falls into one quantum mechanical object. So when Ken Shoulders, as I said at the start of my presentation, said that in an exotic vacuum object, you can have, let's say, 1 billion electron charges, and he can vary that all down to 1. That is effectively like a muon is a lepton with a single charge, and a tauon is a lepton with a single charge, like an electron, but they're different masses. What happens is it becomes one quantum macro object. So, for instance, we've demonstrated, if you go and look at the remote-view.icu, we have an experiment where we've created a ball lightning, and it presents one magnetic moment. And as it cuts the tungsten and it falls down, the ball lightning that's attached to the piece of tungsten magnetically aligns with another ball lightning that's on the structure. And so the entire sheath is coherent. And how this occurs is because you have a double layer. And as I was showing you with the soliton from the physics paper that I shared in my presentation, there is a double layer on which you get what's called electron bunching. And wherever you have electron bunching, you will force coherence. So that's what's happened in the Perovskikov paper, where they're using the vortex coming down and they're cohering that way. In this Mikhail Solin patent from 1992, he uses an electron beam arc furnace. So he fires the beam and he uses a low vapor pressure refractory metal, so something like molybdenum or tungsten. And these are metals that will melt, but the melting to boiling point is very, very large separation. And they force electron coherence. And he says everything you need to know in his 1992 patent. He says this forces 2 solitons of 2 different magnetic charges, which then cluster together to form tubes and cylinders in which nuclear reactions take place all the way towards the collapse of baryon matter. And so this is actually destruction of matter and conversion to light and leptons effectively.
So basically, in a nutshell, coherent matter is matter that acts like one unit.
Like a laser is one very, very powerful photon type of thing at that frequency, and it packs a punch. But the laser has no mass. In this case, if you start adding mass, then you can add vastly amounts more energy. And
basically what I'm getting at is, at what level is it coherent? Because you could have coherence in temperature, you could have coherence in
so let's go back to the beginning. Let's go back to the beginning. To create coherent matter, you need to get the same atom isotope into the same
not how to create it, but what is it? Once it's created, how do you define it?
How do you define it? It's basically the same blob of the whole thing is the same thing. So it's like a macro atom.
Are all of the subatomic particles spinning in the same orientation simultaneously?
Yeah, they act as this. They act as their own unique exotic vacuum object. They're like an electron is a vacuum object. An actual atom, say sodium-23, the whole thing acts as a vacuum object. When you become coherent. So the important thing with that Lockheed Martin patent that I learned from it is that you can actually create coherent matter at any temperature whatsoever. You just need to have the same thing, like the same atom. Like, so for instance, aluminium is fantastic. It's highly conductive. It's highly thermally conductive, and it's single atom isotope. So this is very, very good for creating coherent matter. This is why it was one of the best elements for
that's what we're using in our dynamic nuclear orientation experiment. But it sounds like you're talking about the same thing what we're doing with Altifon. And he talked about using dynamic nuclear orientation, which is a magnetic, a laminar magnetic field is applied to a piece of aluminum, and then you hit it at the gyromagnetic ratio of the valence electron, which is 28.025 gigahertz per Tesla. And if you pulse it at that rate, you're able to transfer coherence of the magnetism. Magnetism is spin orientation of electrons. You're able to transfer that to the core of the atom.
It all sounds awfully complicated.
It's actually pretty simple. It's actually pretty simple.
But it sounds awfully complicated.
It does sound awfully complicated. When you see what it is, it's just magnetism and microwaves.
So in the 1950s, a British university found that if they took a piezoelectric material, say, and they used quartz and they used microwaves, they could use the fact that it can transduct the EM waves into phonons within the material, and it creates solitons, i.e. sounds at the frequency of the microwave inside the quartz. It would go down the quartz, it would come and partially reflect off the other end and come out, and it would then emit back into an EM wave the phonon that was traveling through. And via this, they published in New Scientist in 1963 that you can convert electromagnetic waves into nuclear vibrations. And they showed that they could get to 10 megagigacycles or whatever they call it. Anyway, it's in the microwave range. And basically, this was the same vibrational distance as the distance between the nuclei in atoms, which means you could then create resonant nodes that are at the interatomic spacing. And so if you take that, when I visited the Hutchison lab in Germany, I grabbed one of Hutchison's sample, which was a piece of aluminium that was affected. And I said, if I was to create in this system to make this coherent, so it could create this coherent nuclear transmutation effect or coherent matter effects, I would want to have a piezoelectric material on the outside of this. And there's a number of ones you could use. So the first one that was any good was barium titanate. And then you had PZT coming out in the 1950s and so on. But before that, you had quartz. And so the ancients would have typically used quartz. And quartz is in much rock, so you can use that. So all you need is sound or electromagnetics. Now, the coherent matter process occurs at any frequency. So for instance, in a Mars vibrator plates, they're running at typically 179 hertz, and you can see the resonant nodes. And in the resonant nodes, you get the coherence. And once the coherence starts, the current system grows out of that. Now, in the Vega Valley, which is very important, I'm going to be publishing a book on that. That produces coherent matter structures that then bleed into each other, and they produce a very large structure that goes over a large area. In this book here from 1995, and you can go and get this off remoteview.icu, the pages that are relevant. Matsumoto is describing that by creating coherent matter ball lightning, by creating within the metal lattice, you create emission of electrons, and you create this coherent state by the electrons being bunched with protons in there. You create the coherent matter. That is superconducting. And when the zones get big enough, they wet together, just like they did in the macro sense. And then the whole material becomes superconducting. This is what I was talking about when I visited the Hutchison lab in 2018, January 6th. And subsequent to that, the US naval labs came out with their Salvatore Paya patents, where they put PZT on the outside of a piece of aluminium, and they use pulses and electromagnetic waves. You need the polarity and you need the pulses. This creates vibration in the material at the nodes, the nodes where there's no vibration. You force the temperature of those monoisotopic atoms of aluminium to be exactly the same. And at the point that they become exactly the same, you start to get coherent matter of aluminium. And then when those zones get big enough, just as was basically that patent is invalid based on what is in Matsumoto's pre-published book, by the way, that you can throw that out of the window. That means we have any temperature superconducting available for us to use for free. Goodbye, US Navy. And so
that patent pretty much describes the Alzaphan experiment, which is magnetic fields and then pulsing it at the gyromagnetic ratio.
Anything that produces vibration, be it electromagnetics converted into solitons, or sound. Sound will do it. You know, this is what brought down the walls of Jericho. It was sound. You know, it's the tool. So I have an experiment which I talked about briefly, where you can buy a $35 ultrasonic cleaner and a sheet of aluminium in water. The experiment takes 20 minutes to learn, and it produces yin-yang. It literally yin-yangs, and they're two extremely fast rotating toruses of charge-separated water. So you have easy water on the outside, you have a plasma in the center. I might have lost my connection. Have I lost my connection? Anyway, no. You have a plasma in the center. This is spinning round. This creates a magnetic, basically a skyrmion. And you have a north and a south skyrmion. And it has an intense magnetic field. And it produces an EVO. It produces an exotic vacuum object. We see all of the same functions, and it produces coherence. And you can transmute within about, well, my experiment that I did for the demonstration experiment, which to learn how to learn it, when I looked at that under the scanning electron microscope, I think I ran that for about 360 seconds. And I synthesized boron, I synthesized many elements all the way up to silver, copper, zinc, and so on. And some of them are in this coherent matter structures. So it's like a pure blob of copper, but it's coming out, it's growing out of the aluminium. So basically, it denatures the atoms into a coherent matter state, and it crushes it beyond that. And then, depending on the pressure that they come out of the system, you get different atoms synthesized. But in the coherent matter state, once you could, so for I'm saying with the ARV, they're using quartz, and they use barium titanate, and I think, or certainly they were using quartz, and I think they were using bismuth. You would use bismuth as something to put for the magnetic field to push against. So bismuth is good for that purpose, because it's got the highest diamagnetic property of any element. And so you would want to use that. It's a natural reason to use that. And so by having the piezo material in there, you are creating sound from whatever electromagnetics you're using. So if you have a Tesla coil, it's got a high frequency resonant frequency, that will create electromagnetic waves, which can be converted with the piezo into sound, and the sound will then start creating these nodes in which these solitons using relic neutrinos will form, and they will then bleed out, because they do. So the very first time I saw these marks, it was in copper. It was in copper oxide, actually, which can become a superconductor itself. And so I think those capacitor plates were covered in copper. So the copper will store, and then they will emit these structures, and they will get caught up into the vortex. And this gets into the torsion field theories of the Russians. So Shishkin said you can create torsion fields very easily in an environment with spinning, rotating bodies, any spinning, rotating bodies, and they will persist, and they're locked to the local space-time. And they're very dangerous for humans, actually, for biology. And he says the only way you can get rid of these things is to use an intense electrical discharge, and it basically disrupts the material. Now, you could walk into a room where it has a torsion field generated, and what the torsion field is doing is in the relic neutrinos in the room, and they're spinning around and spinning around. So using this technology, you can have something that doesn't move the air, but floats above the ground. You understand what I'm saying? It could literally float there. You couldn't feel anything. There's nothing you could feel. But it's creating a shield from the gravity. And so the means by which you do it is to create the coherent matter to start with. That allows you to build these structures, and the structures allow you to traction and interact with the physical vacuum, which in my view, is a large proportion of the useful bit of it is relic neutrinos.
Right. I think we're talking about the same thing, just different ways of accomplishing it. And
yeah. Help me understand how it is that you're trying to achieve it.
So we're doing something called EPR, electron paramagnetic resonance. It's similar to NMR, like nuclear magnetic resonance, but instead of flipping the entire atom over and back and forth again, you're hitting the Larmor frequency of the valence electron, which is the ratio at which it, the electron precesses. And that is dependent on the strength of the magnetic field. So there's a ratio of 28.025 gigahertz or billion times per second per Tesla of magnetic field that's applied. And by pulsing RF into a system that has this homogeneous magnetic field across the entire sample, you're able to energize those electron spins. And then when you remove the RF momentarily, that extra energy does not get converted into heat. What it does is it transfers orientation to the core of the atom. So magnetism being spin orientation.
Okay, I think you need to look at the Aharonov bomb effect. I think you're describing something similar, which is the mechanism by which Lockheed Martin are employing the Aharonov bomb effect to synchronize the atoms' frequencies.
That may very well
and
be.
that they use a magnetic field to do that. Once
a magnetic field and then a pulsed RF. This is what the extraterrestrials are doing as well. We've seen flying saucers flying around with pulsed pulsed gigahertz RF and emanating out of them every like 5 milliseconds or so, which is about the pulse rate you'd need at room temperature for aluminum. You know, that's like the max pulse rate that you can achieve.
So I don't know about aliens, but I'll tell you the story that I've now made public a number of times. When I was around about 7 years old, my father, he described himself at one point as the most senior Mason in the UK. He invited me and my three brothers and one sister downstairs one late summer night. And he said, kids, I want you to look up into the heavens there. And so we all did that dutifully, looked up into the heavens. It was a beautiful, clear, black sky. And these four lights went, flew, just disappeared with an intense flash in formation. And he said, right, kids, now you can go to bed. Now, I know my father was not an alien, or at least I'm pretty sure he's not. And but I do know that he had US Navy contacts from his time in the Navy, and he was highly respected. So, and I am 49 now, and I think I was around about 7 at the time. So this is 42 years ago. So definitely, I think basically he'd probably got to another level in the lodge, and that someone said, look, we'll do something for your kids. Be here at this time, look up into the sky. And there we go. So I don't know about aliens. I'm pretty sure that our species probably got to this planet using this technology, because the science is adding up to make that perfectly possible. But I'm not sure that the ones that I saw as a child were alien.
They probably weren't if he had information on it.
No, I think they were British military. So I don't have a problem.
You can call it British at that point, because like once you're that high up, it sort of becomes planet Earth.
Well, yeah, but I mean, I don't think he had any contacts with like Americans or Russians or whoever. You know, I know his contacts were in the UK Navy. So
right, the stuff that we've seen, like in the Old Testament, you know, those kind of miracles that can be explained by this same phenomena, and the earlier flying saucer stuff, like even before Roswell, those could only be explained by extraterrestrial.
Yeah, I mean, it's absolutely reasonable that we get here. Like I say, it just seems fairly obvious now. I never expected, when I set out to see if Martin Fleischmann and Stanley Pons had any truth in what they were doing in 2011 to be where I am today. I had no idea that this would literally be the God's toolbox, but it is.
Yeah, that's what we've concluded as well. Well, if you're ever in the New York, New Jersey area, you're welcome to come down to the lab over here and see what we're doing.
Thank you. It sounds great, Mark. I look forward to it.
I guess you're in Britain, right?
Yeah, I just have to get my medical exemption because I already had the sniffles, and my grandfather died of a heart attack when he was 52, and my father died of a heart problem when he was 72. So I absolutely do not want any clot shot.
Okay.
So I have to get a medical exemption.
Okay.
Hey, can anybody hear me? Is this an open session now, or?
Yeah. Well, let's do open session now. So actually, Aiden, though, I think Phil Bouchard wanted to present some results first. He's been pestering me. Do you think we could do that? If we could get Phil on, and then could you go after that, Aiden?
Yeah. I just had a question for Bob Greenyer, because the plasmoids, the soliton.
Okay. Well, yeah, go for that then, and then we'll do Phil after that. So
it's can you talk about creating or getting a soliton to stand still in a material so you can do work with it? Is that some, because this research that I'm working on, the Manella circuit, he essentially, it's following in the footsteps of like Floyd Sweet, the vacuum triode amplifiers. If you reference that, research that, the vacuum triode amplifier, you'll get into this. But we're conditioning ferrite, and we're putting a torus into it so you can pulse it with RF energy to get a standing plasmoid or a soliton, a vibrating ring on that. And then if you combine it with the right pickup circuit, then it has been observed to cool the ambient air or the temperature around it, and then it provides a steady voltage source after a while, so that and everything you were talking about with the solitons, it just started to click. So
okay, so first off, I'd say go and listen to my 2013 interview with Brian Ahern, who worked with Manelis. He gives a lot of information away in that. And then there was if you look, there is another, that's on the MFMP's YouTube channel. There was another person that interviewed him shortly afterwards, following on from that interview, and there's extra details. I will be doing a review of those soon. But again, it's creating a kind of superconducting state in there, and you will want to be creating these exotic vacuum objects that are embedded into the material.
Right.
And so the question, they do stay indefinitely in the material. Now, I talked about some living for 2 days. I talked about them living for 2 months. We were able to reinvigorate them by exposing a reactor to heat after 9 months. And then I told that to some of the Russians, and they said, oh, we just put some of our bismuth out into the sunlight, and we were able to produce strange radiation emissions 18 months later. So it's a bit of a contest now, who can get them to be reinvigorated longest. Now, I know there was problems with the Manelis device. And so,
well,
yeah,
so I'm in on the, as far as I know, I have technical details or a briefing on it from Tom Vallone. So I've talked with Brian Ahern over the summer. I was offered an internship up at Lanel, but the winds of karma blew funny on that one.
You signed your life away.
But I'll have to look. I guess I'll through Tim or whatnot. Can I get your contact info so I can?
Yeah, sure. You can pass that on, Tim, please.
But in the report, to bring the circle back to the beginning, the report said the effect that they were able to create was short-lived, lasted about 15 minutes, and that they had, in order to get it to stay stable and be able to do work in the ferrite, they had to wrap these coils around it and then get those powered. So
I think I remember. I might be wrong, but there might be a discharge.
Yeah, no, I mean, I have pictures of the circuit element that worked. That he had two, one in the car and one in the house. So I've been trying to reproduce.
But what is your discharge component that you're using?
Oh, the discharge is, so it's basically this conditioned ferrite with the coils wrapped around it 3 times. That's your wheel. The plasmoid is trapped in there. And then he used, it's a modified Bedini schoolgirl motor.
Mm-hmm.
And so he used 5 of these jewel thieves as a capacitor diode ladder filter in order to keep the output centered. And then anything over like 180 volts, it would, the filtering process would send it out as usable voltage. And then you would put that back into your battery system, and would start reconditioning your batteries, or just applying a positive voltage source, which would recharge your batteries. So that's.
I what I mean is, I think there's some a pulsed discharge in the system that
yeah, no,
triggers it.
Well, so it's using these jewel thieves, which are like a solid state ACE transformer. The initial pulse comes from their magnetization equipment. And like I said, they would get that, they condition the ferrite, put this toroid into it, hit it with another coil, which would get that would be your pulse. And I guess they had the frequencies at which they were hitting the ferrite. This has got to be, I mean, we're in shop talk off the top of my head on the fly. But the coil, the frequency of the pulses have got to relate to the size of the torus in the magnet or in the ceramic. And then I have a half-assed picture or a fuzzy picture of the coil that they used. So I'm going to duplicate that over the next couple of weeks. We got a lot.
Okay, well, I mean, I think we probably take this offline, but I don't know. You kind of want to set up some sort of permanent magnetic skyrmions, which are kind of like these things in the material, and that they will suck in energy, and it's grabbing that energy that's converting it to electricity, as far as I can understand.
Right, right. Mark, hey, Mark, go get out my first ferrite. The one that you showed me. Well, we had the magnetic flux paper.
Talking about a block.
We had the magnetic flux paper on it. And then,
1 second.
Like I say, how much time have you spent speaking to Brian?
Several months over an email, but Dr. Vallone gave me all of the technicians' papers that, so I've been reading over that for about a year.
You're way ahead of me on the studying of this particular thing, probably, as well as if you've been looking at suite. So maybe I can look at the materials and think of their appropriateness.
Yeah, we're going long. I think I need to yield this back to Tim, but we should connect.
Yeah.
So
Yeah,
take it offline.
let's do that.